Okay, so some people asked me to do notes from the very last thing we did because that is going to be the last thing that they're going to test on the AP test. So some of you guys, this would be review. God, I don't know what's wrong with this. I'll try this again. All right, let me try it again. Separable differential equations. So, just to review, you have a differential equation, for example, dy over dx equaling, I'm going to start out simple with this one. Let's say x over y. The whole point is to get the equations, to separate the equations as in each variable on the same side. So you want all the y's on the left and all the x's on the right. Remember, dx over here needs to be in the numerator. It has to be on the top. So if I wanted to separate this, I would have to multiply by the y that's down here and multiply by the dx that's over here. So what you get is y dy equaling x dx. Once you've separated the variables, you can now integrate. So, remember from what I said before in class, for any of you guys that were absent, the whole goal of this is to get y by itself, get the original y equals equation that caused this differential equation, to cause this derivative. So first you have to integrate the antiderivative of y. It's y squared over 2 equals the antiderivative of x. That's going to be x squared over 2 plus c. Remember, why do we have the c? We don't have any limits, so we have to have a plus c. Now, if I gave you an initial condition like, y of 0 equals 4, then we can use that to eventually figure out our c. So, starting from here, so we've got y squared over 2 equaling x squared over 2 plus c. And then I just told you that the initial condition is y of 0 equals 4. So now remember, our goal is to get y by itself. So first thing you're going to do is multiply everything by 2. So you're going to have y squared equals. So you have to multiply the whole right side by 2. Well, x squared over 2, the 2's cancel out, so you get x squared plus, remember, c is just a constant, right? So a constant times 2 is just going to be another constant. Now here, you can use this to figure out your actual c if you want to and plug it in. So remember, 4 is the y, so that's going to be 4 squared equals, you get 0 squared plus c, or c equals 16. So now you've got y squared equals x squared plus 16. You still have to undo the square root, the square, by taking the square root. So that cancels out, but when you take a square root, you get plus or minus. So which one is it? Well, because this is a positive 4 over there, it's going to be y equals the positive square root of x squared plus 16. And that's the original equation that gives us that differential equation. We can try another one. Let's see. We could do the one that we started out with in class. That was probably the most difficult we can get to. Let's say I said dy over dx equals, we'll do x times y. All right, and I'm going to let you guys know that the initial condition is, let's say, y of 0 equals 5, whatever that's going to be. So again, first step, differentiate the equation, separate the variables. You get 1 point for separating the variables. Got it? So all the x's have to go to the right, all the y's go to the left. Well, since this is times y over here, that means you're going to have to divide by y. So you're going to get dy over y equaling, you multiply by dx, x dx. So you get 1 point just for that on the AP test. Next step, integrate. Now, what's really in front of the dy over here on the left is just a 1. So this is really 1 over y. The antiderivative of 1 over y is the natural log of y. Remember, absolute values every time you do it with natural log because you can only natural log positive numbers. Equals antiderivative of x is x squared over 2. And then you still have to have the plus c. So this line alone is 2 to 3 points on the AP test. 1 point for each antiderivative. You get a point for the plus c. Now, remember what we said. Our whole goal is to get a y equals equation. So I have to get the y by itself. So how do I undo natural log? You e it. Right? So you get the absolute value of y equals. Now, before I split this up on the right to review for the people who are absent, remember what I said about x squared times x cubed? That's really x to the 5th because it's 2 plus 3, right? We're going to go backwards, where I'm going to go this way, where I'm saying, hey, I've got exponents that are adding. I want to split them up into two things. And I'm going to bring the 1 to the c to the front. So this is going to be really e to the c times e to the x squared over 2. Then, how do we get rid of absolute value? You plus or minus. So y equals plus or minus e to the c, e to the x squared over 2. This is sloppy. This is crazy, right? So I can put in, come back over here. So y equals plus or minus e to the c, e to the x squared over 2. This gets a little too much. Let's clean it up a bit. Remember, c is just a number. E to a number is just a number. Plus or minus that number is just a number. So instead of all that, plus or minus e to the c, I'm going to call it the letter a. And just say that's our number. That's our constant. So y equals a e to the x squared over 2. Now, our initial condition from the very beginning where I said y of 0 equaled 5. So 5 is y equals a e to the 0 squared over 2. Well, this is 0. E to the 0 is just 1. 1 times a is a, so a is 5. So my answer just becomes y equals 5 e to the x squared over 2. That's how you get the final answer. That's our differential equation. I'm sorry, that's our original, that's our solution. That's our y equals f of x. So make sure that is pretty much the gist of what we're going to be doing at the end. Your homework, I believe, for this was on, let's see, was it 7.4? And it was just questions 1 through 10 on page 361. If any of you guys have homework questions on that, email me, let me know. We could also do it on a hangout sometime this week. Sometime Tuesday or Wednesday, though, I will be calling you guys to talk to you about figuring out who is taking the AP test and all of that. All right, bye.